Okay, well, thank you all very much for showing up on a cold, blistery night, and really appreciate that you're here. Feel free to help yourself to some cheese and sourdough bread during the talk. You don't have to stay there. You can get up and have that, and feel free to ask questions at any time. I want to thank the organizers for inviting me here. It's really appropriate to give a library talk. My wife is a librarian, was a librarian, and she was worked in public libraries and also in academic libraries. She was in the age before computers, she was really good at getting information. She always knew how to get resources. And we'd been here a few years at the university. We had young kids at the time, and she was home and she called me in the morning and she said that one of the kids had left a stick of butter out overnight on the kitchen table, and she wanted to know if it was okay to eat that butter. And a lot of people leave butter out on the kitchen table all the time. So I said, microbiologically, it's perfectly fine. She said, I don't know if that's right or not. She said, I'm pretty suspicious. I think I should throw it away. I said, don't throw the butter away. And she said, I'm going to call the university and find out. And I said, you just called the university. So anyway, okay, so I'm going to cover a lot of material tonight, so I'm going to go kind of fast. If you want me to slow down, I'll be happy to try to adjust my pace a little bit. And get this going. Problem with that? Am I locked up here? That wasn't good. Uh-oh. Don't turn off your computer. It's Windows.
Well, we're going to have to wait. Oh, come on. What did I have?
Well, somebody has a Mac adapter to a projector. Anybody keep a Mac adapter around?
What, you need HDMI to?
I have the Mac, but I don't have the little adapter to fit into the projector. Do you have that?
I might. Is that what you need?
Yeah. No. It's the what is that? Yeah, it's
The little thunder thing.
Thunder thing is what I need.
They don't have it in media services, Janetta. We've already checked.
Sorry.
We'll start this up again. Let's start. You want to check the CDRA?
Dr. Hutkins, I have a question.
Yeah.
Since you're thinking about it, I noticed on the first slide you said fermentation provides visually appealing products. I'm aware of other fermentation that is not visually appealing.
So.
Yeah, people will eat it still.
A good example are some of these cheeses and breads that are, they have a crusty appearance on a bread, or a cheese with colors, and blue cheese that have different appearances. Great example is Swiss cheese with the eyes.
Right.
The eyes have no flavor.
Swedish delicacies, fermented herring and things like that.
Sure. But a wine that's got, I'm going to talk later about champagne, that's got bubbles.
Yeah.
I mean, there's some mouthfeel to the bubbles, but you look at it and it has clarity and the bubbles. So that's, I think, visually appealing. That's what I'm getting at. Is it still turning off?
No, it's reconfiguring.
Jessica went up for.
Yes, yes, yeah.
All
We'll
right.
see if we can find you an adapter.
You're going to edit this delay out, Mike?
Yes.
All right.
For the online audience, this lecture went.
Yeah.
So this is a good time if you need more cheese and
Yeah, grab
crackers,
some more cheese.
Get some more.
Yeah, if you needed a bathroom break.
And people give lectures without PowerPoint all the time, but it's been so long since I haven't had to
all
do that I don't know how to do that anymore. Okay,
There you go.
let's see where to go.
Yeah, it's still loading.
Oh, there it is, right
Yeah,
there. Okay. Still thinking.
Yeah, this is a slow.
Okay.
Ah,
Is that it?
uh,
Please tell me that's it.
I think it might be.
'Cause I'd rather we use yours.
I think that's it, isn't it, Mike?
Yep.
Yep, fabulous. All right, let's get this thing out of here.
Thanks, Jessica.
Sound good?
Yes, thank you very much. Yay.
What?
I said I just pulled it out.
Oh,
of
you
my
just
monitor.
got-
You need this one.
I don't think I'd need that.
Put this in your pocket.
Okay.
Do you want to use the clicker or are you going to use your?
I'll just have to use my hand here.
It should work with the clicker. It should,
What?
It'll work.
It'll work with the clicker?
Yeah, put it in.
All right. There we go.
Okay. What do I do with the clicker?
In your pocket? Is it in your pocket?
Maybe.
It's in there.
No, don't yet.
Okay.
Okay, let's test it. Point it to the computer. Yep.
Excuse me.
All right. All right. Okay. Okay. All right. So first, I want to thank donations from Open Harvest and Shadowbrook Farm Dutch Girl Creamery for providing the cheese. The bread is from Le Cordier. That's a sourdough bread. I'll talk about bread in just a few minutes. Okay. So I am on East Campus. That's our building for the time being. You know it by the dairy store if you're not familiar with East Campus. Our food science department, this is just some promotional material I'm required to give. We're well known for our food allergy program, applied genomics and ecology, food safety and engineering, and also this gut function group, which is part of our gut health program, of which I'm a member of that group. And if you haven't been reading the newspaper, you would know that, that we're moving to Innovation Campus this fall. So that's going to be food science in these two buildings. My own research program involves gut health. I work on various gut health issues, food safety, lactic acid bacteria that are important in food fermentations. And I am the author of that bestseller, well, not quite, published in 2006. I'm now on a sabbatical, rewriting that book for a second edition. It did actually okay. Between the Harry Potter book and my book, collectively, we've sold 500 million copies. Okay, so here's the little outline for this talk. I'm going to cover some general principles, a little history, a little microbiology, and some examples of fermented foods. So if you took a biochemistry class or a biology class, you'd get this kind of definition, kind of a biochemical definition of what a fermentation is. But I like this food-friendly definition, which is which is much more encompassing, converting raw materials into finished fermented products. Okay. For example, milk into a variety of cheeses, meat into a variety of sausages, fermented vegetables, cabbages, olives, cucumbers into the fermented vegetables that we're familiar with, flour into bread, malt into beer, grapes into wine, rice and soybeans into Asian fermented foods like miso and soy sauce and tempeh. And even things like coffee and cocoa are fermented. Okay, so there's a long history of fermentation microbiology and the production of fermented foods. I just want to spend a few minutes going over some of these, and I'm going to go quick. So in all of the Western religions and Eastern religions, fermented foods play a major role. In Genesis, Noah's first order of business after the flood, plant a vineyard. The very next line is he got drunk. Okay. Wine's a sacrament in Judeo-Christian rituals. It's mentioned in mythology. And just the availability of bread has played a major role in the course of Western civilization. Just a few highlights that I'll just point out on this is milestones in the history of fermented foods. So if agriculture began 10,000 years ago, which is a reasonable, good estimate, fermented foods came along shortly thereafter. In the Roman Empire, 14 million bushels of grain are imported. That's about 20% of the Nebraska amount of grain produced today, 2,000 years later. Roquefort cheese discovered in the caves in France. In the Far East, a company called Kikkoman still exists. I'm going to visit Kikkoman in Wisconsin on Monday. A sake company in Japan is currently still in business. Moet and Chandon, a great champagne, about 300 years ago. Guinness founded about 250 years ago. Thomas Jefferson tried to start a wine industry in Virginia, and that didn't work so well. The age of microbiology starts with Pasteur and Lister, both working on fermented foods. Kraft, of course, 100 years ago develops processed cheese. Carasso forms Dannon. That's actually started in Spain, not in France. And then we're in the modern era where genomes of the bacteria and yeast and mold that are important in fermentations are sequenced and studied. And what do we learn from, and this is from my lab, this is an organism called Streptococcus thermophilus. What do we learn from studying organisms all the way down to the gene level? Well, here's a set of genes called EPS, stands for exopolysaccharide cluster, and they form a polysaccharide that's like a gum. And why are there gums in yogurt? Those are the genes. It gives yogurt that viscosity that you like, that people tend to like. So it's important to study all the way at the molecular level. Okay, so how are fermented foods different from those traditional foods that I just mentioned or modern technology? So hundreds of years ago, 100 years ago or so, everything was done on a small scale, on a craft basis. Now, I've been into some very large cheese factories, wine factories, and you have huge volumes of product being made with just a handful of workers operating computers. Everything is done on a very large scale, very automated. In the old days, fermentation was very insensitive to time. If the bacteria or the yeast were running slow, it just meant that you're late for dinner. Okay? You can't have that anymore. The modern industry is very time sensitive. If the bacteria or yeast are working slow, then the shift is off. You're paying the workers more. You can't fill the vat a second time. So it's very time sensitive. In the old days, you might have quality. One day, one year the wine is spectacular. The next year it's not so good. The hallmark today is consistency. That's sort of Western thinking, is to be consistent. And of course, up until 150 years ago, there was no knowledge of microbiology. Now we know all the genes that are in the organisms that are used to make these foods. Okay. And why do we like fermented foods? Several important reasons. Number one, the most important, is that they are well preserved. Some of them have enhanced nutritional value. How many of you eat yogurt? Maybe you like yogurt, you like the taste of yogurt, but there's the perception that it's healthy for you. Enhanced functionality. Flour is flour. You can't do too much with flour, but if you add some yeast to it and knead it and let it rise, you get these wonderful breads. They taste good. Organoleptic means that they taste good. They're visually appealing, they smell good, they taste good. They're unique, so you can't make most of these foods any other way other than fermentation. And they have increased economic value, and I'll give you a good example. My last trip to Italy, in the Florence region, I bought this, whoa, I don't want to drop this. This little box, well-packaged box, and in the box is a really small little container. Anybody know what this is? Real balsamic vinegar. The balsamic vinegar you buy at the grocery store for $4 or $5, it's fine, but it's not the real thing. This is the real thing. 90 milliliters, $100. Okay, it was 70 euros. It's just vinegar. Okay, and you know wines. Wines can get very expensive as well. Okay, so most of the fermented foods we eat and drink today are made using modern technologies. If you go to Europe, and even places in the U.S., they're using sometimes traditional procedures, and often they're required to use traditional procedures. So that vinegar that I just showed you, the reason why it's so expensive is that they make it on a small scale according to slow traditional procedures. That vinegar, I think, is 15 years old. So if you think about any kind of enterprise, when you put the money into something and that you can't sell it for 15 years, it's going to be expensive. It has to appreciate. Okay, otherwise you put your money in a CD or something. Okay, so there's all these designations in Europe for making foods the old-fashioned way. And now in the U.S., there's this whole movement over the last 20 or so years, this artisan or crafts movement to make all sorts of foods. In fact, the cheese here is from an artisan cheesemaker here outside of Lincoln. Okay, and so here's some examples. Roquefort cheese has to be made according to these very rigid specifications. The milk has to come from sheep that graze in this region of France, has to be made according to precise conditions, and the mold, called Penicillium roqueforti, has to be from the caves in that region of France. Here's a bottle of champagne. This is the region of Champagne just east of Paris. Again, the grapes in the region specified, how the grapes are grown and how the wine is made has to be very specific procedures. And I'll talk more about that later. And here's the little balsamic vinegar. This is how you serve it. A little bit of it, stick a piece of cheese in there or a piece of bread in there. You don't dress a salad with this stuff. It's too expensive. Okay, so I always like to point this out. I have one of my students that's taking my fermented foods classes here tonight. And I make this point in, I think, the first lecture, that it's a very fine line between what's spoiled and what's properly fermented. Okay, so wine is a good example. You don't want wine tasting like vinegar. Okay, so it's a very fine line between what's good and what's not so good. And left to their own fate, perishable foods, meat, dairy, vegetables, grapes, will all spoil on their own due to uncontrolled growth of microorganisms. In fermentation, we simply control the conditions so that only the so-called desirable microorganisms are able to grow and flourish and produce end products. So, here's a piece of Roquefort cheese, nice blue cheese. It's about, in the US, maybe $15, $16 a pound. And this cheese, if you saw this in your refrigerator, what would you do with that? I guess you could trim off the mold if you wanted to. But you probably would throw it away, okay, because it's moldy. Okay, I guarantee you that there's a very good chance that the mold that's growing on this cheese is Penicillium roqueforti, the same mold that produced the $16 a pound cheese and that tastes so nice. Okay, so what's the difference? Is that here we controlled the conditions by which the mold grew, and here they were uncontrolled. Okay. So making fermented foods requires, of course, microorganisms. And they can be introduced into foods one of three different ways. They can be, and I put this in quotation marks, naturally present in the food. Microorganisms are always going to be present in milk, meat, vegetables, and so forth. And we simply create conditions to let the appropriate organisms predominate. Okay? And this is how a lot of foods are still made this way. So most of the wine that's in Europe is made this way. Sauerkraut is only made this way. Kimchi is only made this way. And soy sauce, for the most part, is also made that way. A second way to introduce organisms is by backslopping. That's when you take a perfectly fine fermented food, take a portion of that, and add that back to the fresh raw material. And this is, I picked this up this morning from Le Cordier. They make sourdough breads, and they were kind enough to give me, they call this a sponge. It's kind of a wet dough that they could then use to inoculate fresh dough, and all the bacteria and yeast are in here. Now, I could take this home and make Le Cordier breads if I knew what I was doing. Okay. And a lot of breads are made that way, as well as sausage, beer, kefir. The other way, and the modern way, is to use a starter culture. And here's a starter culture. It's a frozen can of highly concentrated bacteria. Marshall Superstar, concentrated culture, contains selected strains of lactic acid bacteria suspended in milk solids. And you just put this into the cheese vat, and that will carry out the fermentation. I have another one for putting this into a batch of meat to make sausage. And here's another one that contains Propionibacterium. Elizabeth, do you know what cheese that would be for? I don't have it here. Propionibacterium. I probably haven't gotten to it in the class yet. Anybody know? It makes propionic acid and carbon dioxide. And so what cheese do you think you'd put this into? Swiss cheese, exactly. Okay. Now those are frozen. The more common way, and they still sell them that way, but they've gone to a freeze-dried, which is a powder. You could just pour that in, and it's very popular now in the industry. And most of the fermented foods that are made on an industrial basis are made that way. Okay, and so I mentioned organisms usually include bacteria, yeast. I'll come back to that in a little bit later. And there are lots of foods that are made with mold, not just blue cheese. So you might not realize this, but when you use soy sauce, that's a mold fermented food. There are a lot of mold fermented foods you might not realize. Okay, so we're going to go through some of my favorites. We'll go through cheese, sourdough bread, beer, and champagne. Okay, so to make cheese, it looks pretty simple. Milk, add the appropriate bacteria, add an enzyme, and the enzyme simply causes the milk to go from a liquid to a solid or to a gel, basically. And that's basically it. And then you cut it up into curds, and you end up with cheese or curds and whey. That's very simple. But how do we account? I only have a half a dozen cheeses here. There's thousands of cheeses produced around the world. How do we account for all those different cheeses? Well, it's not quite so straightforward. So this is cheese manufacturing unsimplified. And you can see there's so many variables. So you could use cow milk, sheep milk, goat milk. So I have all three of those over there. There's a couple of goat milk cheeses. It can be raw. It can be heat treated. It could be pasteurized. You could add color. You could use whole milk, reduced fat milk, or you could take whole milk and add some cream to it, like some of those Bries. That's why Brie is a very rich, high-fat cheese. They actually add cream to it. Okay. Then you have all these different bacteria that you could add. You could add bacteria that kind of do special things, like Propionibacterium, molds like penicillium. I'll talk more about some of those. There's other things that you could add, like, so chymosin is the enzyme that is there to coagulate the milk, but there's something called lipase. And a lipase is an enzyme that reacts on milk fat and causes the milk fat to become rancid. If you tasted fresh milk, fresh sweet milk out of your refrigerator that had been treated with lipase, oh my God, you would gag. It would have butyric acid. It would be terrible. Terrible, terrible. Okay, you would reject it. Why would they ever add lipases to milk to make cheese? Do you ever want that flavor? Did anybody try this feta? Did you like it? Pass it around. You don't have to eat it. You could take some and pass it around. So feta cheese has lipase added to it intentionally, and it's very rancid, salty, acid. But if you are expecting it, it's perfectly fine. Okay. Okay. It's the fine line between spoilage and appropriately fermented. Okay, and all sorts of other variables that I'll mention as we go through some of these cheeses. So I'm going to talk about a blue cheese called Gorgonzola. It's made in Italy, and I was there in 2014 in this little factory called Novara, Italy. And here are the steps of cheese making. They pasteurize the milk. This is the culture. This is the chymosin. They add the chymosin. The milk sets up as a gel. They slowly cut it, form these curds, which are then pumped into this vat. Then these workers scoop the curds into these forms with some cheesecloth there and let it sit for a while. You can see the whey exude off of there. And eventually they have wheels. The mold spores grow inside the cheese. Now molds, usually if you have mold growth on a food, is it usually inside the food or on the surface of the food? It's on the surface because molds are aerobic. They require oxygen or air to grow. But look at these wheels. How, you saw where's my blue cheese? Here's the wheel of blue cheese. I'll pass this around. You don't have to eat it if you don't want to. But you could see the mold is on the inside. How do they do that? So here's the machine that they had at the factory. So molds like Penicillium roqueforti are aerobic. So how is the interior aerated? This isn't the only way you can do this, but this is common. This is how they did it at this particular factory. They put the cheese right on this little plate here. And it's hard to see here, but there's needles coming out of this top plate, and they simply mechanically aerate the inside of the cheese. They just poke holes in them, okay? And that aerates the inside of the cheese so that mold can grow on there. And if you where's my blue cheese for a second? Okay. Notice, you didn't like it?
I'm lactose intolerant.
Oh, okay. Well, if you're lactose intolerant, I'm not going to say you specifically, but people that are lactose intolerant can often eat cheese.
Certain kinds.
Because lactose is the sugar that's in the milk. What happened to the sugar that was in the milk? Most of it goes out into the whey, and the rest the microbes got. So a lot of cheeses, especially like that Parmesan cheese that's aged for a long time, there's no lactose in there. So, for what it's worth.
Yeah.
But notice this. You see that line right there? That's one of the needle spikes where the mold grew along the spike. So, okay.
Does that mean there are a type of milks that lactose intolerant people do drink then?
No. All milks have lactose. Okay, another cheese that I have over there is Brie, and that has a different mold. It has Penicillium camemberti. It grows on the surface. They don't poke holes. They don't let it grow on the inside. And this cheese has a lot of ammonia to it. Now, ammonia, who likes ammonia? Nobody likes ammonia. But Brie cheese has an ammonia flavor, and if you're in France, these cheeses here are pretty, I could just tell by the surface, they're pretty white. They're not very well ripened. I have a little camembert wheel that has been sitting around for a long time, and I could just tell it's got a little bit more color on the outside, and it's still fairly mild. But if you go to France, you'll find people that like these cheeses with a real strong ammonia flavor. I mean, you could like wash your floors with it. Again, it's a fine line between spoilage and fermentation. Now, I have two mold ripened cheeses, the Brie and the blue, but the Brie comes this way and the blue comes this way. Shape matters because the flavors of the mold are coming from the mold growth and the enzymes that they're producing, and they diffuse into the center of the cheese. And the same thing sort of for the mold. But if I tried to make this cheese in this shape, what would happen? By the time these flavors kind of diffused into the center of the cheese, what would be the flavor on the outside? it'd be way too far gone. Okay, so shape matters. And cheesemakers learned this, 500 years ago that was important. Okay, there are also cheeses that have organisms, the bacteria that grow on the surface, and I have one that's local that is this guy here, Arabella washed rind. And Arabella is just a fanciful name that the cheesemaker used. And you could see, did you taste this one?
Yeah.
Did you like it?
No, I haven't, but
Okay.
I'd be happy to.
Okay. So notice the color of the surface here. It's kind of orangish. Okay. There's no dye on. They don't apply a dye. Where's the orange coming from? The bacteria. Bacteria produce an orange pigment. You were asking me before about the, you don't have to eat it if you want to. These are typically pretty strong flavored. So that's a natural orange pigment that the bacteria produce. And a lot of people don't like those. Sometimes they're called stinky cheeses because they're pretty flavorful. And in the United States, that's known by, we call them Munster. And in the United States, a lot of times if you buy Munster at the grocery store, it's not very strong flavored. In fact, it's bland because they don't put bacteria on here. How do they get the color? They just paint some natural kind of a vitamin A kind of a material that gives it the yellow-orange appearance because Americans don't like those kinds of strong flavors, most Americans. And then there's these Dutch cheeses. I don't have samples of these. But who's had these cheeses before? Okay, what is this on the outside here? Wax. And it's characteristic of these cheeses. And so if you see these cheeses, it's got the wax, you know what it is. All these cheeses that I've talked about, like this Munster, I didn't talk about the Parmesan, but Parmesan has a real hard rind on the surface. A natural rind. What's all that surface material for? Why do cheesemakers kind of encourage that surface material, whether it's a wax or a rind or a mold or a bacteria? To keep it anaerobic and to keep not just other organisms away from the cheese, but what else? This is before we had saran wrap. Okay, oxygen. What else? To keep away. Vermin, insects, mice. Mice like cheese. Okay? And so to keep all those things away, cheesemakers learned, wax or hard rind would be effective. Okay, there we go. There's the Parmesan. Okay, in fact, I forgot I had this. So this is Parmesan is, again, one of those protected cheeses. It's made in the Bologna area of France. And right near there is another cheese is made called Grana, which is almost the exact same as Parmesan, just made in a different region. And I was fortunate enough to go to a factory, and this is a cheese that's made according to very rigid specifications. Small cheese vats, copper-lined cheese vats, small scale, and let me see if I can get this to work. And they just have a whole bunch of these cheese vats and just a handful of workers, and they just kind of stagger all of the steps to make this cheese. It's very cool watching that. Okay. Yes?
Is the copper for flavor or what they have?
The copper doesn't really do much for flavor. That's a good question. It's thought to help the milk coagulate better, but that's just strictly for tradition. Okay, strictly for the tradition. Okay, so let's move on to bread. Those are some nice looking breads. Okay, so quick evolution of bread making. Bread making started out in the home, in the cave, in the tent. Industrial bread making actually began 2,000 years ago in Egypt. It was one of the first large-scale industries that existed. By the Middle Ages, bread making was a craft industry. In fact, all these fermented foods were really crafts. Skilled tradesmen made these foods. And they had artisan bakers in every village. And then when cities grew, artisan bakers gave way to technology. And now we have industrial bread is the norm. And so there's industrial bread. And this is the standard kind of white breads that if you're as old as I am, we grew up with these white breads, Wonder Bread, 3 for $1. And they were what they were. And maybe you all like those breads, so I don't want to say anything bad about them. Kind of just something to put the peanut butter and the jelly or the bologna or the cheese to make a sandwich. Okay. These foods, breads, are made with yeast. And you could buy these yeast in different ways. You're familiar with some of these. This is a compressed yeast. Factories will buy these in big cakes. You could actually buy yeast in liquid form if you're a real large volume maker, or these smaller scale that you're familiar with at home. Okay. There's a real interesting history of baker's yeast. And here's a real interesting paper that came out a few years ago, where basically they say that yeast have followed humans and vice versa. And yeast have been domesticated by humans, much like dogs and cats and domesticated farm animals have been domesticated by humans. And like other domesticated organisms, they've been bred, forgive the pun, for specific functions. So there's brewing yeast, there's baker's yeast, there's wine yeast. They're all Saccharomyces cerevisiae. They all have the same genus and species, but they're optimized for different applications. Okay. Now there's a special kind of bread that has yeast and bacteria. That's called sourdough bread. And the nice thing about sourdough bread, there's lots of good advantages, has a really good shelf life. Sourdough bread, if made properly, hardly ever gets mold on it. Other breads get mold. Why doesn't sourdough bread get moldy? What makes sourdough bread sour? Lactic acid and another acid. It's mostly the other acid called, what was the acid in here? Acetic acid, exactly. Acetic acid is a great mold preservative. Okay. And it has lots of unique flavors and qualities, and it might even be nutritious because it might, it's thought to even people that are gluten intolerant or have celiac disease might even be able to tolerate a little bit of sourdough bread. And there's all sorts of bacteria that we find in there. The most famous is this guy here called Lactobacillus sanfrancescens, because it was isolated at a USDA laboratory right near there, and they gave it that name. One of my all-time favorite moments as a professor was I was asking, I didn't show the slide, and I asked the class, the fermented foods class, does anybody know the species name of the lactobacillus that's involved in the sourdough bread? And a student raises her hand, and she says, I think I know this. She says, I know what it is. She says, it's Lactobacillus sacramento. And I go, what? Sacramento? So she was off by about 50 miles. Okay. But so here's a factory in Germany. So you can get really old school with some of these technologies. So I showed you that modern factory. How old school is this? This is a wood-burning bread ovens. This is just outside of Munich. I mean, how old school is that? Okay, and they make these wonderful breads. Okay, so let's move on to beer. I don't know. Beer will change the world. I don't know how, but it will. Okay. So beer also has a great history. This is from the Journal of the Pilgrims at Plymouth. We could not now take time for further search. So, why did the Pilgrims land at a rock? Okay, that doesn't make any sense. They had to land somewhere because they were running out of their provisions, mainly their beer. Okay, they would much rather have landed on some nice beach, but they had no choice. Okay, beer was gone by Christmas, so the first order of pilgrim business was build a brew house. So that's all documented in that diary. The history of beer actually goes earlier than the Pilgrims, of course. This is the first food laws, outside, I guess, of the Bible. The first food laws were these of 1516, the Reinheitsgebot, the German impurity laws, that established that beer can only be made with 3 ingredients. Now, the modern take on the Reinheitsgebot is 4 ingredients, but they only identified barley, hops, and water. There was a lot of unscrupulous beer makers that were putting in other things into the beer to add shelf life and to give it flavor and so forth. And so to protect the Bavarian beer industry, they made this restriction. What was the fourth ingredient? Yeast. And why wasn't it identified in 1516? They didn't know about yeast. Exactly. So here's the first beer factory, 1040. Okay, so I visited there a couple of years ago as well. It's all modern on the inside, but that's a 1,000 years old, that factory. And here's a nice patent on how to improve the beer process. And I don't know if you could see the author of this U.S. patent. Can you see that? Can somebody read that for me? Louis Pasteur. He actually wrote the patent and made the drawings, and it was a way to improve beer processing. Okay, so only 4 ingredients are necessary to make beer: malt, hops, water, and yeast. And they're all important. The hops we'll talk about in a second. The malt's important. Of course, the yeast are important. I'm actually from St. Louis. I think this is Rocky Mountain water from Coors or something. I'm from St. Louis, and I grew up on that Mississippi River water that they make Budweiser out of. Okay. Okay, so there's 4 ingredients, and there's 4 steps to making beer. I'm not going to go through this in much detail. First is to make the malt, which is one of the main ingredients, and the malt provides flavor, color, nutrients, and other things. And it's the malt that, when you get a beer that has these darker colors, it's the malt that gives those colors and flavors. Okay. Next step is mashing, in which the carbohydrates in the malt are converted to sugars that the yeast can ferment. This is a process called mashing, and you end up with this fermentable material called wort. Then we inoculate, or pitch it's called, with the yeast, and they ferment in these tanks, and you end up with beer, but the beer at this point is kind of cloudy. Americans don't like cloudy beer, so you go through clarification and filtration. You can even pasteurize the beer. Okay, so now we're going to fly into the wine fermentation. So, how many of you how many would you define yourself as a wine drinker? Okay. Beer drinkers. Okay, wow. Okay, well, you're not going to like what I'm going to have to tell you. So, so this is the IQ of wine drinkers versus beer drinkers. First thing I got to tell you, and this is a given, you know this, that men are smarter than women. Men, you know that, right? You don't want to admit that? Okay. But wine drinkers are smarter than beer drinkers. So especially, so here's the wine drinking men, way smarter than wine drinking women, and both groups are way smarter than beer drinkers. So the study was very flawed because they didn't control for like demographics and other things. But it was interesting. Okay, so how do you make wine? So surprisingly, the process for making white wine versus red wine is not the grape. A lot of white colored wines are made from grapes that look red. It's not the grape. The difference is that the red wines are fermented in the presence of the skin and the seeds. That's a step called maceration. And the fermentation in the presence of the skin and the seeds the alcohol draws out the pigments from the skin and the seeds and makes red wine red. So champagnes are made from Pinot Noir. A red grape is used to make, in part, champagne, which is generally a white wine. Now, how many of you, parlez-vous français? Somebody. Okay. What does this word mean? Terroir.
It has to do with the earth.
Earth, right. And anybody speak Spanish? What's terra, right? Terra. Okay. So that the root, it's earth, it's land. Okay. I only know that from Gone with the Wind, right? Terra, right? Okay. So the terroir concept says that the quality of the wine is based on all these kinds of physical and even ephemeral characteristics. So things like climate and soil, terrain, tradition make the wine. So if you go to France, they're in my mind, they go crazy with this terroir concept. But you can go to the Napa Valley, and they believe in that as well. And it's kind of why you can't take a Cabernet Sauvignon grape out of Bordeaux and bring it to Lincoln, Nebraska, and grow it in my backyard and expect that you're going to get a Cabernet wine. Okay, I don't have the terroir to do that. I have the grape, but I don't have the terroir. Okay. Here's so I had one of my postdocs actually was French and has a farm in Burgundy. So this is in Burgundy, and Grand Cru and Premier Cru just simply refer to the quality of the grapes that are on their farm, where Grand is better and Premier is the next level. They're both good grapes. It's Burgundy. But it's 8 feet separating these two. But they would claim that these grapes make better wine than these grapes. The way the sun hits, the way the ground slopes, the rain that they get. So that's what they say. Now, this is a colleague of mine, David Mills, at University of California, Davis. And he's a molecular ecologist. And he studies the bacteria and the yeast that live on the surface of grapes and that live in the wineries. And he's argues that in addition to the other parts of the terroir, that it's the organisms that live on the grapes and in the winery that also contribute to the quality of the wine. So he's imposing a microbial terroir, which is a kind of an interesting concept. It's also interesting, I just threw a couple of slides in here, but I've just only last couple of years I've been talking about this, and that's the effect of climate change on wine. And this has been a big issue, not just in the US, but throughout Europe as well. And what they're showing, what they're predicting is that in 40 or so years, that as climate changes, the climates and regions that are suitable for certain grapes won't be, and they're going to shift. And the bottom line is that Nebraska is going to be Napa Valley. So if we live that long. Okay. Okay, and then lastly, there's lots of specialty wines. I only want to talk about one, sparkling wines, of which champagne is a class or one of the types of wines that are defined as sparkling wines. But to be called champagne, you have to, the grapes and the wine has to be made in this region of Champagne, just a little bit east of Paris. And here's a Champagne vineyard that I was able to visit a couple of years ago. And what's interesting about Champagne is that you make Champagne like you would a normal still wine. And so you go through a fermentation, you blend, you put the wine in a bottle, and in the bottle there's a second fermentation when what is produced during that secondary fermentation? Carbon dioxide is produced in that fermentation. Now, when you buy a bottle of champagne around New Year's and it costs $5, how did the carbon dioxide get into that wine? Not this way, okay? They put it in there like they would soda pop, okay? They just carbonate it. It might be perfectly fine. I've drunk plenty of $5 bottles of wine before. Okay, but to make real champagne, you have to go through a secondary fermentation. Now, who's had real champagne or just a nice bottle of sparkling wine? Many of you have? Okay, so one of the key characteristics of such a wine is that it has to have good bubbles, but really good clarity, right? You want to see through it. And so if you have a secondary fermentation in the bottle, you're going to make the carbon dioxide, but the yeast are going to grow, and they're going to be cloudy. So how do you get the yeast out of the wine without losing all the carbon dioxide? Because you open the bottle and the carbon dioxide's gone. So here's I think you could see this. Here's a bottle of, so as that wine is aging, and as it sits on the side, the yeast have settled here. Okay. So the next step they're going to do, I'll show you a picture. I think it's the next slide. The wine sits in an angle. And as it sits in an angle, the yeast kind of slowly, over a long period of time, slide down to the neck of the bottle. Okay? And ultimately what they want to do is get the yeast so that they're sitting flat on top of the cork or the stopper in that bottle. flat on there. So what this guy does, he just gives it a little of a turn every couple of days, a little of a turn, so that the yeast sit on there flat, okay? And I thought that, I knew about this technology. I thought, and we were at the champagne house, and he said, oh, the guy, this is called riddling. He said, the guy's going to be here any minute, and you get to see him do that. And I thought, I don't know why I thought this, but I thought he was going to be decked out in some uniform or something. And the guy just shows up in a T-shirt, you know. He's got like 10,000 bottles that he has to do. He just does that all day long. Just gives it a little of a twist. I don't know what I was thinking, but he's done. Okay, so now they've got the yeast sitting on the top of the cork here, or the stopper. And then what they do is they pass this through, inverted, they pass this through a freezing bath so that the neck, the wine and the yeast stuck to the cork or the cap are frozen. Then when they flip it over, they can pull that off with the yeast stuck to the stopper, and they're good to go. And then they could just fill it. They lost a little bit of wine. They could fill it up with a little more wine to keep the volume back where it was, and they're done. So that's what there's going on here. And on the next one, so now they've reverted it, and there's a frozen yeast plug there. And they're going to pull that cap off of there with the yeast plug stuck to it. So they're decapping it, and then they're going to fill it with a little bit more wine to get the volume back to where it's supposed to be. And put a fresh cork in it. That foam is after they put more wine into it. It gets corked. The extra wine that they put into it, if you buy champagne, you can get it sweet or semi-sweet or dry, and it's how much sugar is in the extra wine that they've had to add at the end that influences whether it's dry or sweet. And then just mix it, give it a little mix. I'm going to wash off the bottles. And then these wines, I think these wines US are around $60 or so, but it's just amazing how much wine is being produced. This is a small champagne house. And just to show you kind of the blend from traditional to like modern, you know, so that they're using a robot to move these bottles around rather than, you know, manual. So again, it's a good mix of tradition and modern. And then just a couple more slides, and then I'll be done. Have you heard of the French paradox? So this is what I like to always point this out to my wife to justify my wine drinking habits. The French paradox says that despite people in France eating cream and cheese and butter and all that stuff, kind of a high-fat diet, that they don't get heart disease because they drink a lot of wine. And the study's kind of flawed, but I buy it. Okay. And so then lastly, you know, I kind of gave you fermentation 101, a little bit of philosophy 101. You know, from the Bible, go thy way, eat thy bread with joy, and drink thy wine with a merry heart, for God has accepted thy works. Wendell Berry, American essayist, eating with the fullest pleasure is perhaps the profoundest enactment of our connection with the world. And the poet, Charles Simic, says, when our souls are happy, they talk about food. So again, I want to thank the donors of the cheese, Open Harvest, and Shadowbrook Farms Dutch Girl Creamery, and thank you for your attention.